Welcome to math lesson 4.9. We're going to do some multiplication patterns using powers of 10. So you will need out an indigo color and a violet red. That's going to end up looking kind of like a bluish purple and a bright pink. So again, the colors are violet red and indigo. If you're having a hard time finding those colors, you can use a red or a blue, but try to make the colors close. This is a lot to set your journal up for. So I am actually going to talk through this while you set your journal up. So there's not going to be a pause unless you get behind. So go ahead and write the title, Multiplication Patterns Using Powers of 10. And then put 4.9 with the date in the box where it belongs. And then you're going to write these things. I'll give you just a second to get those things written. Multiplication patterns using powers of 10. And it's lesson 4.9, and you put the date in the box. Okay, so I have first put over onto the left-hand side these boxes, and I colored one, and it was bigger, and I colored it the indigo color, and I wrote base. And then I colored a little tinier box, the violet red color, and I wrote exponent. So you're kind of making a key for yourself over here on the left, so make sure to do that. And then every time you write the number 10, you're going to be writing it in the indigo color. And every time you write the little tiny numbers that are called exponents, that are to the right and up above, you're going to use a pencil if you want, and then you can outline it in the violet red, or you can just do it with the violet red. So I want you to right now write 10 to the first power, 10 to the second power, 10 to the third power, and 10 to the fourth power. It looks like this. 10 with a little baby 1, 10 with a little baby 2, 10 with a little baby 3, and 10 with a little baby 4. What that is saying are these phrases to the right. 10 to the first power, 10 to the second power, or it can also be said as 10 squared, 10 to the third power, which is also 10 cubed, and the last one is 10 to the fourth power. Go ahead and pause the video and get all of those phrases written. If you have unpaused the video, it means that you have gotten all of the phrases written. And then I want you to, over here on the right, I want to prove it to you what that means. So we've learned this a little bit before, but we're just going to review it. The little exponent is the one in charge, and it tells the base how many times to throw itself down. So to throw the base or drop the base. Okay? So on 10 to the first power, there's a little baby 1. So the little baby 1 is telling the base, the exponent is telling the base, that we want it to drop a 10 one time. So over here on the right, I have dropped a 10 one time. And if you just have 10 and you're not multiplying it by anything, what does that equal? Hopefully you followed that. Okay, let's take a look at the next one. 10 to the second power, or 10 squared. So again, the exponent is the one in charge, the little 2. And the little 2 looks at the 10 and says, hey, 10, I want you to throw yourself down 2 times. So I throw 10 down 2 times. And they're multiplying by each other. We're not adding. And we're not doing 10 times 2. We're doing 10 times 10, or we're doing 10 twice. 10 times 10 is 100. So if I were to ask you, what is 10 to the first power, you would say 10. If I said, what is 10 to the second power, you would say 100. But you need to know what it breaks down to. So take a look at 10 to the third power. Sometimes we can call that 10 cubed, because the number 3 means a cube. 10 cubed would mean I take 10 3 times. I don't do 10 times 3. I throw down 10 3 times and multiply them by each other. So over here on the right, you can see I threw down 3 10s and I multiplied them together, and 10 times 10 times 10 is 1,000. If you didn't know that, you could break it down like 10 times 10 is 100, and 100 times 10 equals 1,000. So you can kind of break it down if you want to do that. And then 10 to the fourth power just means I throw down 4 tens and I multiply them together. So I have 4 tens over here on the right and I multiply them together. Well, 10 times 10 times 10 is 10,000 because it's really simple when you're doing ones and zeros, right? What's 1 times 1 times 1 times 1? It's 1. And then how many zeros were there supposed to be? There's supposed to be 4 zeros. So it's a 1 with 4 zeros, which means it's 10,000. So that is kind of the pattern of what's happening. Sometimes people pick up on this pattern, so I'm wondering if you've caught it yet. But 10 to the first power is just a 1 with 1 0. Is 10 a 1 with 1 0? Take a look at this one. 10 to the second power should be a 1 with 2 zeros. Is 100 a 1 with 2 zeros? Yes, it is. Let's take a look at the next one. 10 to the third power means it's supposed to be a 1 with 3 zeros. Look over at your answer. Is 1,000 a 1 with 3 zeros? Yes, it is. And lastly, 10 to the fourth power should be a 1 with, you guessed it, 4 zeros. So is 10,000 a 1 with 4 zeros? Go check it. Yes, it is. So that is what bases and exponents are. But I really want to make it clear that the exponent has all of the power. That little tiny number up in the right-hand corner of the number has all of the power. It tells the base how many times to drop itself and multiply together. So let's go ahead and write that phrase. The exponent has all of the power. I'm going to be writing this under the pink line. Again, the exponent has all of the power. I'm going to put an exclamation point on that. The exponent has all of the power. The reason why I like to use the word power here is because, like we said in the phrases above, it's 10 to the first power or 10 to the fourth power. An exponent means power, so that's why we're going to use that phrase. So we circle the word exponent in our statement and circle the word power. So another word for exponent is power. It's just how you can pronounce it. But this is a really helpful thing to remember. The exponent has all of the power. It tells the base, so go ahead and start writing that. It tells the base. I'm just going to write it down here. It tells the base how many times to drop it tells the base how many times to drop itself and multiply together. The exponent has all of the power. It tells the base how many times to drop itself and multiply together. We're going to underline the word base in our indigo color, and we're going to underline the word drop. So the base drops, the exponent is the power. The base drops, and the exponent is the power. I really want you to understand this phrase, and I want you to remember it. So what we're going to do is over on the right-hand side, we are actually going to draw a stop sign so that we stop and think about what that phrase is meaning. So we're going to use our indigo as the pole for the stop sign, and we're going to use the violet red for the stop sign. But I'm going to draw it pretty big over here on the right of the phrase, and I'm just going to be drawing a stop sign. So you do your best to draw a stop sign, and we'll see what they look like later. So a stop sign is an octagon, so it needs a top and a bottom. It needs a total of 8 sides. Well, the way I've drawn it, it's going to end up being a hexagon, so I need to erase mine and start over. I think I can do it like this if I make these longer. Oh, actually that was correct. Oh, it's not exactly. Mine's really wide, but that's okay. So really stop and think about what this phrase is saying, okay? It's saying the exponent, that little tiny number, has all of the power, because it's called a power. And it tells the base how many times to drop itself, or drop the base. It's going to tell you drop the base 5 times or something, or 4 times, or 2 times. Whatever it says, you write that number down that many times. It does not mean that you multiply it by that number. You're going to be multiplying them by themselves. It does not mean that you multiply them together. That needs to be very clear when you think of that statement. Okay? So, let's just practice this a little bit with some more tens. Okay? Let's try 10 to the 5th power. So I'm going to write it in pencil. I'm going to write it down here to the left. So 10 to the 5th power would look like this. Use the right colors to outline it. That says 10 to the 5th power. So what that means is that little 5 is the one that is powerful, right? Remember, stop and think about it. The exponent has all of the power. That little tiny number, that 5, has all of the power. It tells the base how many times to drop itself and multiply together. So let's go ahead and do that. It says the 5 tells the 10, hey, yo, 10, you're the base. I want you to drop 5 times. So the 10 is going to drop itself, or write itself, 5 times. So it means 5 tens get written. And the other part of that phrase says, and multiply together. So each of these tens gets a little multiplication sign in between. What is 10 times 10 times 10 times 10? If you have a hard time with that, you can break it up and branch it off into little things, or you can just remember the trick with 1s and 0s, or the beginning trick. 10 to the 5th is a 1 with 5 zeros. This only works with 10s to be able to do it like that, a 1 with 5 zeros. Or you could just go 10 times 10 is 100, 100 times 10 is 1,000, 1,000 times 10 is 10,000, and 10,000 times 10 will be 100,000. But if you didn't know that, you could draw a 1 with 5 zeros. So sometimes I just write the number out and then I decide where to place the comma. Where does the comma belong in that number? Right after 100. So it would say 100,000. That's your final answer for 10 to the 5th power. So if someone were to say to you, solve for this, solve for 10 to the 5th, you could do it. That's all it is. It's this type of math problem. Well, you need to know something really important about exponents. They have really cool powers of 10, not just exponents, but powers of 10 have a really cool pattern and relationship when it comes to decimals, to multiplying and dividing with decimals. So what it ends up doing is making the number shift into higher place values. For example, when I multiply something by 10, it gets 10 times greater. If I multiply something by 100, it gets 100 times greater. So I'm going to just write this phrase at the bottom. Multiplying decimals by powers of 10 will help us find some patterns. So I'm going to write this at the bottom. Multiplying decimals by powers of 10 will help us easily find a pattern. I'm actually going to say will help us easily find patterns. Multiplying decimals by powers of 10 will help us easily find patterns. I want to put that in an indigo cloud. And I'm going to draw a red-violet arrow to the right, indicating that we want to turn the page. So on the next page, we're going to be practicing multiplying decimals by powers of 10 and finding out if we can see what the shifting pattern is to be able to just solve these a lot quicker. So go ahead and turn your math journal page. Now we're on the back side of the journal. So we're going to put at the top of this, multiplying decimals by powers of 10. This has just kind of become our new title, because now that we've practiced powers of 10, we're going to put it to use. So let's begin with this pattern. We're going to be doing 1.7 4 different times. So I want you to write 1.7 and skip a line and then write 1.7, do that 4 times. So I'll show you over here on the left. So I've written 1.7 and now I'm going to come not to the next line underneath it, but the one after that. We're going to skip lines and I'm going to write this 4 times. The first one I'm going to times by 10 to the first, then 10 to the second, 10 to the third, and 10 to the fourth. Make sure you really write the base big and the exponent small, so it doesn't look like 10 something or 103. It needs to look like they're different sizes. So 1.7 times 10 to the first, 1.7 times 10 to the second, 1.7 times 10 to the third, and 1.7 times 10 to the fourth. I want you to take your red violet and circle all of the exponents. Make sure you're being very clear about which ones are the exponents. They're the little numbers. And go and underline all of the bases in indigo. So I'm clearly recognizing that the exponent is the one that has the power, and it's going to tell the base how many times to multiply itself by. But here's the deal. I'm not just multiplying powers of 10 now. I've added an extra element. I've added in decimals. So it's going to become a little trickier, but it's pretty awesome. So we're going to write equals, and then we're going to write these big, long answer lines on each one. And now let's break it down a little bit. When I did 1.7 times 10 to the first power, what does that really mean? What does 10 to the first power really mean? So we keep the 1.7, and we multiply it by whatever 10 to the first power means. So we're kind of simplifying the exponent, if you will. What is 10 to the first power, everybody? The little exponent tells the 10, hey, yo, base, 10. I want you to throw yourself down one time. Okay, that's easy. That's what it means. 1.7 times 10 to the first means 1.7 times 10. So what does 1.7 times 10 to the second mean? Well, it means 1.7 times, and then you have to really think, what is 10 to the second? Well, the little exponent 2 tells the 10, hey, yo, base, 10. Throw yourself down 2 times and multiply yourself together. So if I were to throw 10 down twice and multiply them together, it would be 100, or a 1 with 2 zeros. Are you catching on to this pattern yet? Take a look. We have 1.7 times 10, 1.7 times 100. Do you know what the next one's going to be? Probably do. It's going to be 1.7 times 10 to the third. So the little exponent says, hey, yo, 10. I want you to throw yourself down 3 times. And 10 times 10 times 10 is 1,000. So if you guessed 1,000 on this one, you are correct. And now we're on to the next line. 1.7 times 10 to the fourth means 1.7 times, and whatever you think 10 to the fourth is, it's a 1 with 4 zeros. Or you can just take a look at the pattern here. We've got a 10, 100, and 1,000. It's going to be multiplied by 10,000. So that is what it means. You're going to have to break up what it means. And then I'm going to show you this really cool thing when it comes to the answers on all of these ones. What is the final answer? So now we kind of can cover up the left-hand side and just deal with the right-hand side. If I have 1.7 and I multiply it by 10, there's something really fascinating about the number system that we use. We use base 10 number system, which means we only really use a total of 9 digits, right? Because once we get to 10, we have shifted over into another place value. Think about this for a minute. Count with me on your fingers. You ready? Literally, show your fingers as we count. 1, 2, 3, 4, 5, 6, 7, 8, 9. And the next one you're going to say is 10. But when you say 10, think about writing the number 10. Is it just 1 digit? No, it shifted to 2 digits. So it shifted over into the tens place. So this is why it's called the base 10 system. It's what we use here in America. Most countries use the base 10 system. Not every country in the world does, but most do. And so you just have to look at this and go, okay, if I'm multiplying 1.7 by 10, then all of the numbers are shifting up a place value because our place value system are by tens. Think about it. We have the ones place, and then what's directly to the left of the ones place? The tens place, right? What's directly to the left of the tens place? The hundreds place. So as we move left, it's getting 10 times greater every time. What if we move right? After the decimal. Think about that. Tenths to hundredths to thousands. It's getting 10 times smaller every time. So that's pretty cool. So the numbers actually do some shifting here. So it looks like this. If I have the answer, it would look like you still have to have a 1 and a 7, but they can't be in that same place value. The 1 has to be 10 times bigger than it is now. And what is a 1 times 10? Or if I just move it over, it's in the tens place, right? And the 7 has to be 10 times greater than what it is now. And it's in the tenths place. So what's the place value that is 10 times bigger than that? It's the ones. So you kind of have this whole system. I'm going to go ahead and write this out. Put the decimal like this in between these 3 dashes. So we have right here the tenths. So I'm going to write it as a fraction. Then we have the ones, and then we have the tens. So it looks like 10, 1, 1/10, with a decimal that's separating the wholes and the pieces. So think about it right now. Where is 1.7 at on this little answer line? It would be right here. It would be above the 1 in the ones place and the 7 in the tenths place. So will you with the pencil really lightly just write it above like this? That's what the number is right now. 1.7. But I'm multiplying it by 10, which means that both of these digits are going to shift to the left. So the 7 is going to move over into the ones place because it's getting 10 times bigger. Numbers get bigger as you move to the left of a decimal. What happens when you move to the right of a decimal? Did you whisper it? Whisper it. What happens when you move to the right of a decimal? They get smaller. So the 7 was in the tenths place and it shifted to the ones. The 1 used to be in the ones place, so where does it shift? It gets 10 times bigger too. It steps to the left. So the 1 comes into the tenths place. So it's 17 point nothing. I'm just going to go ahead and circle it. And I'm going to use the power circle color to show the answer is 17. Okay? All right. So now we're going to be taking that same number, 1.7, and we're not just making it 10 times bigger, we're going to make it 100 times bigger. So they don't just have to take one step to the left. The numbers are going to shift 2 places to the left. So let's just draw a couple out here. Let's go. So again, we have tenths on the right, ones, tens, and hundreds, with that decimal separating the wholes from the pieces. Where did the 1.7 used to be? Look, it's still written up above there. You can see it. It used to be in the ones place, so we're going back to the original number, 1.7. So it used to be here, 1.7. But now we have to get it to shift 2 places to the left because I'm multiplying it by 100. I'm not just moving it 1 place, that would be 10. I'm moving it 2 places because that's 10 times 10, right? It was 2 places, 2 10 places. So the 7 doesn't move to the ones place, that would be only 10 times. It moves a whole other time. So the 7 actually moves over here to the tens place, and that means the 1, you got to move it 2 places too. It used to be here, so moving it once would bring it in the tens. Moving it twice brings it into the hundreds. So what in the world do you do in this situation? It's 1 7 nothing point nothing. You're going to have to fly in a 0 the hero. You can leave the decimal, you can leave place values after the decimal empty, but you cannot leave whole number places empty. You can't just say it's 17 nothing. You have to say it's 170. So will you please circle that with the red, for the violet red color? So the answer became 170. Let's do this again. So think about it. If I drew 3 places this time, how many do you think I'm going to have to draw this next time? 4. Why do I keep writing that little tiny place value? It's because you need to understand that's where it originally started. The 7 originally started in the tenths place. Then I have the ones place, then the tens, then the hundreds, and the thousands this time. Go and touch with your finger where the original numbers were. Where are 1.7? Where are they at in this line? Think about it. The 1 is in the ones place. The 7 was in the tenths place. So they're right here at the end. But I'm asking you to move them 3 times to shift the numbers 3 different place values. Okay, so let's just start with the 7. The 7 needs to shift 3 times. If it shifts once, it gets put in the ones place. If it shifts twice, it gets put in the tens place. If it shifts 3 times, it gets placed in the hundreds place. What about the 1? Well, naturally, it just goes right in front of it. You've been seeing that happen. But let's just start back here. The 1 was originally in the ones place, but I need to shift it 3 times because that's what the exponent says. Well, I'm moving 3 10 places. 3 tens places. So I'm moving it 1 place, 2 place, 3 place. It goes in the thousands place. And you cannot just leave it as 1 7 nothing nothing decimal. You have to fly in more zero the heroes. Those zero the heroes belong in the tens place and the ones place. You could put them in the tenths if you would like, but it's not necessary. So what's the answer to this one? It's 1,700. See how the numbers are shifting? What's happening here? Look at what's the pattern that's happening. The numbers are shifting to get into higher place values every time. They shifted 1 time in 10 to the first. They shifted 2 times in 10 to the second. They shifted 3 times in 10 to the third. And what do you think is going to happen here? If you guess that they're going to shift 4 times, you would be correct. I don't like the way that mine looks, so I am going to rewrite it so that it's not coming off of the line, because you really are going to need space for this. So erase yours if you need to, like I am going to, and only let your 10,000 fit on that initial line. Okay, so I still have all of the same place values. You're going to rewrite this again. What is the place value that's to the left of the thousands? It's the 10,000s place. Okay, where were the original numbers again? Clear over here on the right-hand side. It was 1.7 tenths, right? So it was in the 1.7 tenths. You've got to shift them 4 times because it's 10 to the 4th. I need to go 4 tens places. Or I got to multiply it by 10,000. So I'm just going to move the 7 4 times. Holy smokes, the 7 is now in the thousands place. Where would the 1 belong? In the 10,000s place. Can you just say it's 1 7 nothing nothing nothing? No, you got to fly in zero the heroes to hold place values. And my final answer is this number, and I'm going to put commas where they should belong. I didn't in the last one, sorry. The final answer on this one is 17,000. Can you see that the numbers are shifting? Yeah, the base 10, the power system is so awesome. Instead of stacking it up and having to deal with all the multiplication, you can look for these patterns when you multiply by a power of 10. It only works with powers of 10. So do not try to do it if it's just some other number, like 1.7 times 23. You're going to do your other multiplication skills that we've learned for that. But if it's a power of 10, you're going to be dealing with the shifting. And it's super, super cool. In the next video, because that was so much fun, shifting all the numbers, so much fun, and flying in zero the heroes, well, in the next video, I'm going to teach you a little trick. So we'll see you soon.